is. All right, so today we are looking at our trigonometric equations with trig identities involved. We only have one example for this. So we want to solve our trig equations either in degrees or radians over our restricted domain, and we are going to use our trig identities to solve these trig equations, and they might be reducible to a quadratic as well. So those trig identities that we went through on the board, we can use them to solve our equation. Now, when we're solving any equation, we always want our pronumerals to be the same, right? So normally if we have a quadratic equation, we want like x squared plus 2x minus 3 equals 0. So we have all x's. In this one here, we have to solve 2 sine squared x minus 3 cos x equals 0 for 0 to 360. Now you'll notice that it's not all in terms of sine, or it's not all in terms of cos. So what we need to do is we need to make this all in terms of the one thing. Now we can use our Pythagorean identity, which is on our reference sheet, which is our cos squared x plus sine squared x equals 1, and we can make our sine squared x the subject. So we're going to sub in sine squared x equals 1 minus cos squared x into the equation that we have. So where we have our sine squared x in our equation, we're going to replace that with a 1 minus cos squared x. So what we'll have is 2 lots of 1 minus cos squared x minus 3 cos x is equal to 0. If we expand our bracket, we get 2 minus 2 cos squared x minus 3 cos x equals 0. Now, when we write an equation, we write it from the highest power to the lowest power, and we generally also, when it's a quadratic, want our highest power, our coefficient of x squared, to be positive. So what we're going to do is we are going to technically move everything to the other side, is one way to think of it, or another way to think about it is we're going to multiply every term by minus 1. When we multiply every term by minus 1 and write them in order from highest power to lowest power, we get 2 cos squared x plus 3 cos x minus 2 equals 0. So now what we have is a quadratic equation, but instead of it being 2x squared plus 3x minus 2, we have it in terms of cos. Now, we looked at an equation like this last lesson, and what we do to make this easier on ourselves is we let our cos x equal any letter, but of course I pick m. So what we have is 2m squared plus 3m minus 2 equals 0. Now from here we need to use our factorising skills, so we need to use our SPF. So we have our sum is 3, our product is minus 4, so 2 times minus 2, and so our factors are going to be 4 and negative 1, and then we split our middle term. So we'll have 2m squared plus 4m minus 2 equals 0, and so our 4m minus m should equal that middle term of 3m on the line above it. Okay, so our lines are all the same. From here, we factorise by grouping in pairs. So my first pair of 2m squared plus 4m, I can factorise out a 2m, leaving me with m plus 2. And then in my second pair, minus m minus 2, I can factorise out a negative 1 to leave me with an m plus 2 equals our 0. So then what we get is our two equations, or our two brackets are going to be our m plus 2 and our 2m minus 1 equals 0. So what we'll have is that m equals 2, or it equals a half. Okay, So remember, we're doing our null factor law to solve for a half, but it's also our constant over our coefficient in a bracket as well. So if you needed to, you could have gone m plus 2 equals 0, m equals minus, oh, it should be a minus 2. No one picked that up. Oh, okay, you just didn't want to tell me? Okay. And then our 2m minus 1, so then you'd plus the 1, 2m equals 1, m equals a half. Okay, so if you need to do that work, do the work. It's not bad to do it. So from here, what we want to do is we want to let our m equal cos x again. So what we will get is we will have cos x equals -2, and we'll have cos x equals a half. Now, something we need to look at is our domain. So our domain in this case is 0 to 360. So that means that we're operating in degrees, because 0 to 360 is in degrees. Now, if we have cos x equals -2, are we going to have any solutions for that? No. So there is no solution as the range of cos is equal to -1 to 1. Okay, that is because of our graph. We have enough lines, so we may as well graph it. So 90, 180, 270, 360. Where does cos start? Does it start at 1 or 0? Starts at 1. Okay, so as we can see, x equals -2. If we were to draw this, if we were to draw the line x equals -2, or y equals -2, sorry, y equals -2, it doesn't exist on our graph, correct? Okay, does everyone understand that? All right, now we have cos x equals a half. So we're operating in degrees. We need our ASTC to see where our angles are going to be. Yep, I heard that's correct. It is in our ANC. So it will be our theta, and it will be 360 minus theta, because we're operating in degrees. So cos theta will equal a half. It was positive. So theta will equal, I think, shift cos of a half. It is 60 degrees. Okay, so that means we're going to have that x is equal to theta and 360 minus theta. So x will equal our 60 degrees and our 360 degrees minus 60 degrees. So we'll get x equals 60 degrees and 300 degrees. And so therefore, our own, if we had solutions for cos x equals -2, we would make sure that we write them all together as a therefore statement at the bottom of our page, like so.